learned a little bit about 3D printing and you know how it works, that you print one layer on top of another layer on top of another layer until you get your final project. But it's important to keep that process in mind as you're designing your project. So let's look at an example here. So let's say I designed this table to give to my niece who just got a new dollhouse. And so here's her a miniature table to go inside of her dollhouse. So I've designed it here in Tinkercad, and now I'm ready to slice it and open it up in my slicing program. So here I have the table opened in the slicing program. Let's look what happens as this table is built on the 3D printing plate. So I can watch as it goes up and it's going to build those 4 legs, and then eventually I'm going to get here to the tabletop. Now what do you think is actually going to happen when I try to print this on the 3D printer? You remember gravity? Exactly, it's going to pull that filament right down to the bottom, and I am likely to wind up with a mess. Instead of getting a pretty little table, I'm likely to wind up with a bunch of plastic spaghetti with the filament going everywhere. So what then do? I have a few choices. So the first option I have is, can I change the orientation? Now this is always the easiest option. So remember, I don't have to print something the way that I plan to use it. Obviously, I plan for this table to stand up on 4 legs, but that doesn't mean that I have to print it that way. So can you see another way that I can print this table so that gravity won't destroy it while it's printing? Of course, I can print it upside down. So the way I do that is in my slicing program, I have the option here to rotate my object. So I can rotate it along the x-axis, along the y-axis, or along the z-axis. Now for my table, it doesn't really matter whether I rotate on the x or the y, but basically I'm just going to flip it upside down, which means I want to rotate it 180 degrees. Okay, notice that will flip my table upside down when I slice it. Now gravity shouldn't give me any issues. It'll build the top of the table first and then add the legs on top of that. And I don't have any layers that have to print over air. So let's look at a few examples. Take this cell phone stand as our first example. So I've downloaded this file from Thingiverse and imported it into my slicer. Now I can see by looking at this that I'm going to have some problems when I try to print it. So these arms here, they're floating over nothing. So when the printer tries to print that layer, it's just going to fall down and once again make a lot of plastic spaghetti. So can you find an orientation that will allow this cell phone holder to print without making any plastic spaghetti? So if you look, this here is a flat edge, and if I put that down onto the plate, then I will get an orientation that I can actually print. So this time I'm going to rotate my cell phone holder here 90 degrees in the X direction, and I can see now I have a flat edge that will print. Now you may point out there's a hole here, and so this is going to be printing over thin air. There's also a small gap here where it's going to be printing over thin air, but those are what we call bridges. That's a small enough section that the printer will be able to bridge that gap without any issues, and I won't get my plastic spaghetti. Now let's look at another example. Let's say I wanted to print the screw here. So I've imported it into my slicer and it's on its side, and you can see once again I'm going to have a problem when I print. The threads on the screw are floating in thin air, which is not going to lead to a very nice ability to use this screw. So I need to again change the orientation, and again I can see that the nice round flat head here would make a good spot to put onto the plate. Okay, so I'm going to rotate it again, this time in the Y direction, and I want to rotate it 90 degrees. Okay, now I can see that I stood it up on the wrong end, so I'm going to flip it over by rotating it in the Y direction 180 degrees. Okay, and so now I have my screw in an orientation that will allow it to print. So let's take Rascal for example. As cute and awesome as he is, he has no flat side. So how am I going to be able to print him and not wind up with, you guessed it, plastic spaghetti? So here Rascal is in the slicing program, and as you can see, he has lots of gaps here that are going to be hovering over thin air and will collapse if I try to print him just like this. So what can I do? I can use what are called support structures. Now, engineers use these support structures when they design buildings, for example. They are temporary structures that I put in place to support something until it's strong enough to stand on its own. And so they're put there temporarily just to hold something up, and then when they're finished, they remove those. So in 3D printing, I tell the printer to put support structures underneath my floating parts, and then after the print is complete, I can tear those away with my fingers or with a pair of needle nose pliers. So watch as I begin printing Rascal without support, without a brim, just the way he came in my slicer. As you can see, he won't even stick to the plate because he has round feet, and so that won't even stay on the printer plate. So I just wound up with a little bit of plastic spaghetti before I stopped the print. Now this time I included a brim so that the feet would stick to the bed, and you can watch as the 4 legs for Rascal print pretty well. And then I get to the body, and what do you think is going to happen? I'm going to start getting plastic spaghetti as the printer tries to put filament in thin air. And so once again, I cleaned up my plastic spaghetti and started over. Now for my final print, I enabled supports. So I said I wanted to have support on Rascal, and I have a brim as well. And so you can see as this prints, his legs are going to print, and then his body will print without any problems. Once that gets finished, his head will start printing. And you're going to see that Rascal could print just fine. So now that Rascal has finished 3D printing, how do I actually go about removing these supports? Now Rascal actually tore away from his supports when I went to pull him off the printer bed, so they were very simple to remove. Now a lot of times they will be simple like Rascal was, where you can just grab the supports with your hands and pull them off. Sometimes though you're going to need to get your pliers, so it's a good idea to have a pair of needle nose pliers, and then you can just kind of start crushing the supports and pulling them off until they're all removed. So how do I know when I need supports and when I don't? I like to use what's called the YHT test. And if you think of the letters Y, H, and T, you can see when you need support and when you don't. So I want you to watch as these 3 letters are printed. So I've watched as the base is formed, and you can see here in the letter H, I had a bridge. And that gap was small enough that the printer was able to bridge it without making a whole lot of extra strings. So you can see there's a lot of stringiness all the way across, but generally the printer will be able to bridge this gap without any issues. Now let's keep watching. Now you'll notice here, as the printer begins forming the angle to the Y, that it's able to do so without any issues. The Y is at a nice, gentle, sloping angle. There's enough support underneath it that it continued to print at that angle. So the general rule of thumb is that as long as your angle is less than 45 degrees, you can print it without supports. That will depend a little bit on the material you're using and the layer height and a few things, but generally 45 degrees is your rule of thumb. Now, watch what happens when it gets to the letter T here. So you notice, especially on this side, there is no base for the printer to lay this layer on, and so I get what I call the plastic spaghetti, where it's not able to make a nice clean layer because there's nothing supporting what's underneath it. And so with these three letters, I can say that I can print the letters Y and H, but not so much the letter T. So if I have a sharp angle like the letter T, I'm going to need support. So when you're looking at a design, you want to think, do I have a nice gentle angle like in the letter Y? Do I have a small bridge like in the letter H? Or do I have a very sharp angle with no support like in the letter T? So if I think of those rules, it'll help me determine whether I need support or not. Now, it's best to avoid using supports whenever you can. It uses extra filament, it can be hard to remove, it can leave rough edges on your design. However, sometimes to get a design as fun as Rascal here, supports are necessary. So how do you tell the printer that you want to use supports? So I've imported Rascal into my printing software, my slicing software here. And all I have to do is come over here and change the supports to support on build plate only or everywhere. So notice I have two options. I have that third one. We won't talk about that just yet. But I can choose the option to either support on build plate only. What that means is it's going to start here on the build plate and build support anywhere that Rascal will need those. If I choose everywhere, then it's going to build support on Rascal himself. So let's see if there's any. So if I look at, for example, Rascal's ears here, they might be sticking out a little bit. And so if I choose support everywhere, it might put a little support right there. I probably don't need that. So for Rascal, I'm just going to choose support on build plate only. So once I've selected that option, I'm going to click Slice Now. Sometimes it'll pop up a box. Just click Yes, agree to detecting bridge parameters and so forth. And now I can see that the slicing software is able to add the supports. Now, as you become a more advanced 3D designer, you can add manual supports instead of just using the ones the computer generates to allow you to make some more accurate support structures. But for now, the computer-generated ones usually work pretty well. Now there is one more way to avoid using support structures in 3D printing, and as you become a more experienced designer, it's definitely one you want to look into. And that is creating your design in parts instead of as a whole. For example, in this car design here, I created a car body that has a flat bottom so it will easily print on the printer without support structures. And then I created the wheels that I'll be able to attach with a pin or a screw. And this will avoid using support structures completely. Here's another project that a student designed and wanted to print, but it would be very difficult to print it as is because there is no flat surface for the print to start, so I would need to add supports. And if I did that, I'm going to wind up with rough edges all around the outside of the bottom half of the sphere, and it wouldn't be the nice clean ball that he was looking for. So what I did was take that project and break it into parts, and then each of these parts I could flip or rotate so that they would have a flat edge on the build plate and would be able to print. And then once it was finished, you can assemble it and make it look like the original design. So hopefully now you feel a little more confident using support structures. So whenever you encounter a print that doesn't look like it'll print as is because it has floating layers or strange angles, then think about the three different options that you have. First of all, can you flip the print over and orient it a different way so that it can print with a flat edge on the plate? If that won't work, then maybe you should consider adding support structures. Or if you don't want to add support structures, is there a way to break your print up into parts so that you can print individual parts instead of the entire item at once? So I hope that helps. Happy printing!